Okay, so last lesson, you were working out these partial fractions. And I said that today we would do some integrating with them. I've also realized how to actually make the video a bit better by making the whiteboard a bit bigger. That's as big as I can make it, so hopefully you can see it a bit better today. So I'm just going to do a couple with you. So if we were asked in the exam to integrate this here, actually, can you see it highlighted? Oh, yeah. If we were asked to integrate that there, they might not give you the hint to use partial fractions. So you need to think, well, if it's a fraction, can I use ln to integrate it? And then if that doesn't work, can I use partial fractions if the bottom is factorized or can be factorized? So we've done the partial fractions bit yesterday. So all we're going to do now is integrate it. So if I was going to integrate x minus 3 over x minus 1, that's the same as integrated my partial fraction. So 3 over x plus minus, I'll write it like how I've written it there. Okay, remember the numbers in the top I'm going to ignore. So 1 over x integrates to ln x. And 3, I'm just going to stick at the front. I'm going to ignore the minus 2 at the top. 1 over x minus 1 integrates to ln x minus 1. Now I don't have to divide by anything, because if I differentiate that, I just get 1 anyway. And then I need the minus 2 at the front. So see, that's it. Remember, I need these modulus around my function inside the ln. Okay, so second one. So we've now done partial fractions on this from yesterday. Oh, let's actually give you the answer as well, so you can check that I didn't get it wrong. There we go. So now we're going to integrate that. So to integrate 21x squared minus 13 over x plus 5, 3x minus 1 squared. That's the same as integrating 2 over x plus 5 plus 1 over 3x minus 1 plus minus 2 over 3x minus 1 squared. Okay, so again, ignore the 2. 1 over x plus 5 will integrate to ln x plus 5, and I don't need to worry about a fraction at the front because x plus 5 differentiates to 1. So if I differentiate this, I'll get 1 over x plus 5. So I just put 2 at the front. This one here, again, ln 3x minus 1. But if I differentiate this, I'll need to get times by 3, wouldn't I? So to get rid of that 3, I'm going to put a third at the front. And if you can remember yesterday, my little trick was the bit at the front should be the number on the top over the number in front of x. So here was 2 over 1, it's 1 over 3. And this one, well, this is, we would have rewritten this first as, I'm going to ignore the minus 2 for a minute, 3x minus 1 to the power minus 2. So when I integrate that, it would be power minus 1. But I would have to, if I differentiate that, I would do minus 1 times 3, which gives me minus 3. I don't want minus 3, I want 2. So I'm going to divide by minus 3 times by minus 2, and then the minuses just cancel out. And stick a plus c at the end. Yeah, always check you got the right answer by differentiating. So minus 1 times 2/3 is minus 2/3. I'll take away 1 to the power, so I get the minus 2. That would also have to times by the derivative of the bracket. So minus 2/3 times the 3 just gives me the minus 2. Yeah, if you need to watch yesterday's video to go over stuff like that again, please do. Don't sit and think, oh, I don't get it, I'm just going to give up. I think I'll do 2 more with you. So the next one, again, we've done the partial fractions already. So to integrate 2x squared plus 2x minus 3 over x plus 3 x minus 1. That's the same as integrating 2 plus minus 9 over 4 over x plus 3 plus a quarter over x minus 1. 2, you can do that in your sleep. It's just 2x. This one, ignore the minus 9 over 4. If I integrate 1 over x plus 3, I get ln x plus 3. And I don't need to divide by anything because there's a 1 in front of the x. So in the front, I'm just going to put minus 9 over 4. This one, ignore the quarter. 1 over x minus 1 integrates to ln x minus 1. I don't need to divide by anything because there's a 1 in front of the x. So I'm just going to stick a quarter in front. So C, that's it. Again, you can check my answer. Or I can check my answer, make sure I haven't done anything stupid. Okay, and the fourth one, to integrate x cubed minus x squared minus x minus 3 over x minus 1. Well, we've done the partial fractions bit and we got x plus 3 over x plus minus 4 over x minus 1. So x, you can integrate x to get a half x squared. Yeah, add 1 to the power and divide by the power. Ignore the 3 and just think of it as 1 over x. So that gives you ln x. And then just times by 3. I don't need to divide by anything. There's nothing in front of that 3 there. Just one, sorry, by x is 1x. This one, ignore the minus 4. X minus 1 gives me that. I don't need to divide by anything because there's a 1 in front of the x. So I'm just going to put minus 4 at the front and then plus c. Check we got that right. Good. So can you finish the next 4 off yourself? Like I said, if you need any help with these ones where there's squares in the bottom, go back and watch yesterday's video. Okay, pause it and then unpause it once you've integrated the 4 to check you got them right. And the answers on the screen. Okay, and all I'm going to do now is I'm just going to do 2 or 3 just from scratch as if they were exam questions. So if I can get through that now. Yeah, hopefully you can just see the whiteboard. Good. So first one that we can do is, let's jump straight into some tricky ones. So 8x squared, take away 19x plus 1 over 2x, add 1, x minus 2 squared. Okay, the first thing I would do is I would call that I to save me having to write that out every time I want to refer to it. So I'm just giving the letter I for integral, very imaginative. Okay, what I want you to do is, can you work out what this is as partial fractions? So pause it to have a go at it yourself, and then look in the screen, unpause it to see if you got it right. So I would write this as something over, brackets there, something over 2x add 1 plus something over x minus 2 squared, but I also need an x minus 2. So when I times it by the bottom, I will get 8x squared minus 19x plus 1 gives me a times x minus 2 squared plus b times 2x add 1 plus c times 2x add 1 and 1x minus 2. Yeah, you practiced that yesterday, so if you still need help, go back and look at that lesson. Magic numbers. So first one, I would choose x equals 2. And I'm going to have to use my calculator for this. So 8 times 4, take away 19 times 2 plus 1. This side gives me minus 5. This will disappear, and this will disappear. So I just get 2 times 2 is 4, add 1 is 5, so I get 5b. So therefore, b equals minus 1. My next magic number for this bracket would be minus a half. So 8 divided by 4 plus 19 divided by 2 plus 1 gives me 25 over 2 on this side, hopefully. On this side, this one and this one are turned to 0, so I've just got a pair. So if I put minus a half into there, so minus 0.5, take away 2 squared. gives me 25 over 4 times a. Well, I can cancel out the 25s and times it by 4. So a equals 2. Okay, so that gives me these two. Now there's no more magic numbers, so I just pick any number. So I haven't used 0 yet, so I'm going to stick 0 in to get 1 equals minus 2 squared is 4, so 4a's. 1b, and 1 times minus 2 is minus 2c. So 1 equals 4 times 2 is 8, minus 1 minus 2c. So that gives me 7. Take away another 1 is 6. So 2c equals 6. So c equals minus, sorry, why minus 3? Plus 3. Okay, so I'm just going to change these numbers in the top. So a was 2, b was minus 1, and c was 3. Okay, so now I can work all this out. So hopefully you got the same answer. So now it's a case of integrating them. Well, this first one, actually I'll do it over here so I've got more space. This first one I have ln 2x plus 1. Now at the front I'd have to divide by 2, because if I differentiate that, I have to times by 2. So I need to divide by 2 to get rid of it. But I want the 2 at the top, so I times by 2. So remember that trick, 2 over 2. Next one, so we would have to rewrite that as x to the minus 2 like that. So if I integrate it, I'll get power minus 1. Now if I differentiate this, minus 1 times the root of this, which is 1, so minus 1 times 1 is minus 1. So that was my answer. I don't need any of the numbers at the front. And then the last one, ln x minus 2, but I want it 3 front. Yeah, no fraction, just 3 for c. And then that can just be simplified, build it there to give me that. Okay, let's just quickly look at what would happen. I'm trying to think of a nice number now. What would happen if there was limits on this? What would happen if there was a 3 and a 4 on there? So we would, if that was the case, we put square brackets. I would need a plus c, because that would just cancel out, put 3 and 4. So I would substitute in the top one first, so the 4. So I get ln 2 times 4 is 8, plus 1 is 9, plus 4 take away 2 is 2, so minus 1 is a half, plus 3, 4 take away 2 is 2, so I get 3 ln 2. Take away 7, 3, so that's 6, I want 7, so ln 7. 3 take away 2 is 1, 1 to power anything is just 1. 3 take away 2 is 1, and ln 1 is 0, that just disappears. And then to simplify it, you wouldn't type this in your calculator because it would just give you a horrible decimal. To get an exact answer, you would combine the ln's. So to combine them, I would do ln 9, I would take that power to the top, so plus ln 2 cubed, which is 8, take away ln 7, and put the numbers together, so I've got a half, take away that 1, and simplify both things, so times 9 times is 72, divided by 7, so ln 72 over 7, or it might be nicer just to leave it ln 72, take away ln 7, take away a half. Yeah. Well, I'm sure you knew how to do that. Just do one, just because I know there's one in the exercises you're going to do. Okay, and final one, let's do an input fraction one. So let's integrate 9x squared, take away 3x, plus 2 over 9x squared, take away 4 dx. Well, hopefully, again, I'm going to put this I, in case I need to refer back to it. So hopefully you would spot that this one of it can be factorized. So one fraction would be 3x, take away 2, 3x plus 2, just difference 2 squares. Now, on the top, my degree is 2, bottom my degree is 2, so they're the same degree, so I'm going to end up with a constant as well. So I need something, plus something over that, plus something over that. Okay, again, pause it, see if you can do the Posh fractions bit yourself. Plus b times 3x plus 2 plus c times 3x minus 2. Pick some magic numbers. So x is 2/3 for that one. So if I sub 2/3 into there, so 9 times answer squared, 3 times answer plus 2. So I get 4 equals, well, that'll disappear, so just get that one. So if I put 2/3 into there, 3 times 2/3, 3's cancelled, so I just get 2, add 2 is 4, so 4b, therefore b is 1. Other magic numbers, minus 2/3. So if I sub it into there, I just get 8. So how I did that quickly, I typed this in my calculator, and then when I type this in, I just use the answer button. So to get this, I just changed my 2/3 to minus 2/3, which automatically changed the next line. So I'll just show you my calculator there, look. Yeah, so to do it, first of all, I just typed in 2/3, and I got the answer 4. And then same type it all again, since I used the answer button instead of X, they'll just do it nice and quickly for me. So 8, this one will disappear, this one will disappear, so it's just this one. 2/3 into there will give me minus 4, so minus 4c, therefore c is minus 2. And then pick any random number to get what A is, or you can do it by spotting. So I can spot that A is just going to be 1, because they're just going to cancel out to give me 1, but let's double check. 0 in like 2 equals minus 2 times 2 is minus 4A, plus 2B minus 2C. So 2 is minus 4A plus 2 plus 4. So that gives me 6. Take the 6 to there, so I get minus 4, it's minus 4A, therefore A is 1. So my numbers, put back up here, are 1, stick to the right colours, 1, add 1, and minus 2. So again, I hope you managed to do that yourself. And then to integrate it, well, 1 integrates to x, this integrates to ln 3x minus 2, and I need a third at the front, and this will integrate to ln 3x at 2, I need minus 2/3 at the front, and that's it. So can you complete the practice I give you and ask me if there's any questions?